conditions at that time. And shortly after you began your work here, you did this amazing field project, community science field project about the urban heat island. And all of us in meteorology know what the urban heat island is. It's the urban areas are hotter than rural areas. That's pretty straightforward. There's pavement, there's concrete. But your work really took that farther. And me being a native of Richmond and becoming familiar with your work, and I saw this map and my jaw just about dropped because I want you to go into this, but just as somebody who is a weather geek and a guy from Richmond, I just look at this and I go, oh, wow, I could see the James River, I could see Midlothian Turnpike, I could see Route 1, I could see West Broad, I could see where the airport is, I could see the Chickahominy River, I could see all those things from way out. So talk a little bit about how this map, because it was a big deal. So talk a little bit about the research and what we find out and what we're looking at here.
Yeah, so I guess the spring of 2017, I got a small grant from the Virginia Academy of Science to bring one of my colleagues from Portland, Oregon, the Portland State University, Vivek Chandas, to Richmond to do a urban heat island mapping campaign. And so in the years previous, from 2014 to 2016, Vivek and his lab at Portland State University really perfected the way that you can attach thermometers to cars and then drive around an urban environment and measure the temperature across the town all at the same time. And I said, boy, that would be so cool to do in the South because it's hot and humid here. A different context than the Pacific Northwest. It was a very interesting scientific question, but what we realized was going to be and now looking back on it, the big contribution that we made to urban heat island research was figuring out how to make it an easily learnable methodology. We recruited members of our community through the university systems, so University of Richmond, Virginia Commonwealth University. We had the City of Richmond's Sustainability Office, who had just kicked off their RVA Green 2050 plan, which was just recently adopted by City Council. And we had Groundwork RVA, which is a teen and youth-focused nonprofit here in Richmond, focusing on equitable access to green space. So we had, and the Richmond Times-Dispatch, actually, the meteorologist at that time joined us. So around the table, we had stakeholders from all walks of life, roots to grass tops approach to this. And so recruiting volunteers to take over the methodology is really what transformed this kind of campaign style. So in July 2017, I think it was July 13th, it was going to be 100 degrees. One of those days that feels like you're, outside in someone else's mouth, one of those days. And it was, really, we captured an event that was perfect for the methodology. So 12 different cars with thermometers attached to them. I rode my bike in 100-degree weather, which was probably not safe. Physical exertion, you should probably try and limit that. Hydrate or dihydrate. But the idea was to go out at 3 different time periods on that historic heat event day, 6 a.m., 3 p.m., and 7 p.m. to kind of catch the coolest, warmest, and then evening temperatures. And our teams of volunteers spread out all over the city, driving around at the same time. They carried not only the thermometer that was taking measurements of the temperature every single second, so as they're moving through different land uses and neighborhoods, taking these measurements of air temperature. And then at the same time, they had a GPS unit. And that was keeping track of where they were in space every single second. So you match up these air temperature to place and time. You can then make a statistical model that infills where we didn't have information based on the land uses right underneath and around those measurements. So what you're looking at here is a physical model of taking into account the thousands. We had over 100,000 data points that went into this map that then show us places in Richmond that are relatively warmer and relatively cooler than the citywide average. Sean, we found a 16-degree Fahrenheit difference between the coolest and warmest place at the exact same moment at 3 p.m. during a heat wave. That was more intense of the intra-city variability was higher than some places saw throughout the whole day. So the diurnal variability, the daytime temperature change in some places was less than that 16 degrees Fahrenheit difference within the same city. Just a really dramatic finding. And what's amazing is that when this map was released, we got funding from NOAA, the National Oceanic and Atmospheric Administration, to then go to Washington, D.C. and Baltimore, Maryland in 2018. Then there was Norfolk and Boston and several other cities in 2019. And this has continued to grow. Now over 60 communities nationwide have done our heat mapping community science campaigns. Chicago is one that's going to be doing it this summer. It's very exciting.
Yeah, it's amazing how, working in the climate sphere for a while, every year we would see a new field project coming along with new cities, basically working on the same blueprint that you guys put together. So it's just phenomenal. I could look at this thing all day. But